Welcome to Educator.com. In today's lesson, we'll be working more on quadratic equations and functions, and we're going to start out by analyzing the graphs of quadratic functions. So recall in previous lessons, we discussed quadratic functions in standard form. Today, I'm going to introduce a new form, which is the vertex form of a quadratic function. And this is a very useful form of the function. And it's given as y equals a times x minus h squared plus k. H and k are the vertex of the parabola, and x equals h is the line that is the axis of symmetry. And as you'll recall, the vertex is the maximum point for a downward opening parabola, and it's the minimum point for an upward opening parabola. So by having a function in this form, we already have information about what the graph is going to look like. So let's start out with just a very simple function. Y equals x squared. Okay, so looking at it in this form, we have just an a that is 1, and h and k are 0. So the vertex is going to be right here. Okay, so h equals 0 and k equals 0. So the vertex is 0, 0. Now, drawing some points, x and y. So when x is negative 1, y is 1. When x is 1, y is 1. When x is 2, y is 4, and x is negative 2, y is also 4. So pretty simple graph. Okay, now by starting out with this graph, we can look at what happens, the significance of h and k on the shape of the graph. So we're starting out with just this graph, y equals x squared. Now, let's look at the situation where y equals x squared plus 2. All right, so now I still have an h that equals 0, but here k equals 2. Therefore, the vertex is at 0, 2. Okay, so my vertex is right here. Now let's look at some points, x and y. So when x is negative 1, then x squared will be 1 plus 2, that gives me 3. When x is 1, again y is 3. When x is 2, y is 6. And when x is negative 2, that's negative 2 squared is 4, plus 2 is 6. So look at what happens with this graph. When x is 1, y is 3. When x is negative 1, y is 3. When x is 2, y is going to be up right about here at 6 and right here. Okay, so as you can see, the graph here is shifted, actually starting right up 2. So the graph, the vertex is going to be right here, and when x is 1, y is 3. When x is 2, there we go. So the vertex right here. Okay, so what this is going to give me is a graph that is shifted up by 2. So you see what k does to the graph is it's the same basic graph, but it's shifted up by 2. If k were to be negative 2, then the graph would be shifted down by 2. Now, h also has an effect on the graph, so let's look at what h could do to the graph. Let's take the example y equals x minus 1 squared. Okay, here I have h equals 1, k equals 0. So the vertex is at 1, 0. Now let's find some points. So the vertex is over here at 1, 0. Some points, x and y. for this function. So when x is -1, then that's going to give me -1, and -1 is -2 squared is 4. When x is 0, 0 minus 1 is -1 squared is going to give me 1. I already have the vertex at 1, 0. So let's pick 2. 2 minus 1 is 1 squared is 1. One more point. 3 minus 1 is 2 squared is 4. So that's going to give me -1, 4. 0, 1, 1, 0, which is the vertex. 2, 1, and then finally 3, 4. Okay, so I have this graph right here. So this graph is y equals x minus 1 squared. So you can see what happened is the graph here is shifted to the right by 1. Okay? So h shifts to the right or left. If this had been -1, the graph would have shifted over to the left. So again, k is going to shift the graph either up or down. H is going to shift to the left or right. And we'll talk about A in a minute. So again, vertex form is very useful because it gives you a lot of information. It gives you the vertex, which is HK, and it also gives you the axis of symmetry. And recall that the axis of symmetry is the line at x equals h, which bisects this parabola into two symmetrical halves. For example, if I had a parabola here, downward facing one, and the vertex is right here, the axis of symmetry would be right here at the line x equals h, where the vertex is some point hk. Okay, now let's talk more about the coefficient a. What the coefficient a tells you is how steep or flat the parabola is. For example, if I had one parabola, and let's say it had a equals 1, and it looked like this, for example. And then I had a very similar parabola, but this time with a equals 2. Well, as it says here, if the absolute value of a is greater than greater than 1, the parabola is narrower. So if the absolute value of a is greater than 1, the parabola is narrower. So I have a equals 1, and if I have a equals 2, it's going to be a narrower parabola, meaning that for every x value, for every change in x, y changes more dramatically. So it goes up more steeply, each section of the parabola. Now, if you have an absolute value of a that is less than 1, that is a fraction, the parabola is going to be wider. So a equals 1/2 might look something like this. So for every change in x, the change in y is less dramatic. Okay, so the first thing that a tells us, the absolute value of a tells us, is how narrow or wide the parabola is. A larger number, it's going to be narrower. A smaller number, especially a fraction, is going to have a much flatter, wider parabola. The second thing that a tells us is which direction the parabola opens. All of these parabolas that I showed you open upward, and that means that a is positive. So if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. And here I've drawn a pretty wide parabola, so it would have a fairly small value of a, and it would have a negative value. So the absolute value of a would be small, and the value of a itself would actually be negative. Here, all of these have an absolute value of a. That is, these two are larger. This one's smaller, but all of them have a value of a that is positive. Okay? So they open upward. So if a is positive, the parabola opens upward. If a is negative, it opens downward. If the absolute value is larger, you have a narrower parabola. If the absolute value of a is smaller, you have a wider, flatter parabola. So between what we just learned about h and k and the vertex and what we learned here about a, you can get a lot of information just by looking at the equation about the shape of the graph of the parabola before you've even found points beyond the vertex. Okay. Now, since this is an important form of the equation, you need to know how to write it in vertex form. And you may actually be given a quadratic equation in standard form and be asked to write it in vertex form. And the way you go about that, if you're given a quadratic equation in standard form, is to complete the square. And that will allow you to write the equation in vertex form. Now, it says here that if a does not equal 1, then you need to factor out a before you go on to complete the square. So we'll deal with that in a minute. Let's start out with the simpler case where y equals x squared plus 6x minus 8. So I have standard form, and I'm going to go ahead and write it in vertex form. So now let's just recall vertex form. Y equals a x minus h squared plus k. Okay, so I'm starting out with standard form, and when I complete the square, the first thing I need to do is isolate the variable terms on the right. So here I have my x variable terms, but I also have a constant here. So what I'm going to do is I'm going to add 8 to both sides to get this. Now I have my x variable terms isolated on the right. Isolate the x. I should specify x variable terms on the right. The y stays on the left. Okay, next, complete the square. And recall that in order to complete the square, you need to add b squared over 4 to both sides. Okay, so here, let's figure out so this would give me y plus 8, and b is 6, so that's going to be plus 6 squared over 4 equals x squared plus 6x plus 6 squared over 4. Doing some simplification, 6 squared is 36 divided by 4. That's simply 9. Okay, I've completed the square on the right. I'm going to do some simplification here because this is actually y plus 15. And this is not quite in vertex form because if I look up here, vertex form would have y isolated on the left. So I'm going to actually change this, and I'm going to subtract 15 from both sides. And this is going to give me, let's see, negative 8. Let's see. Actually, one more step. Before we do that, I've completed the square, so I want to go ahead and write this out closer to vertex form before I even go on. And this is x squared plus 6x plus 9, and that is a perfect square. So I'm going to write it in this form. Then I'm going to go ahead and move my 15 over. Okay, so I've written this in vertex form, and I accomplished that by first isolating the x variable terms on the right, then adding b squared over 4 to both sides. I did that, and I ended up with this right here. And I see right on the right, I have a perfect square. So I can rewrite that as x plus 3 squared. And then finally, this is vertex form. And although vertex form has a negative here, it's fine to write it like this. If I wanted to, I could have written it as x minus negative 3. But this is actually acceptable as well. Now, it gets a little bit more complicated if the a term is not equal to 1. So let's go ahead and look at that situation. If I had something like y equals 2x squared minus 8x plus 5. I'm first going to isolate the x variable terms on the right. So that's going to give me y minus 5 equals 2x squared minus 8x. And then, as it says here, I need to factor a out, since a is not 1, before I complete the square. So this is going to give me 2x squared minus 4x. Now I complete the square by adding b squared over 4 to both sides, but you have to be careful on the left. Let's see what happens. So this is going to give me x squared minus 4x, and then b squared over 4 is actually going to be negative 4 squared over 4. Now, I can't just add that to the right, because in reality, what I'm adding is not just negative 4 squared over 4, but it's actually negative 4 squared over 4 times 2. That's what I need to add to the left. Otherwise, the equation won't be balanced. So let me go ahead and simplify this negative 4 squared over 4. That equals 16 over 4, which equals 4. Now, what I'm really adding to both sides is actually 4 times 2. So 4 times 2 equals 8. So this is 2 times 4. So that's what I need to add to this side as well. So this is y minus 5 plus 8 is going to give me y plus 3 equals 2 times x squared minus 4x plus 4. Now I'm almost there because I have a perfect square, which is x minus 2 squared. So then I can rewrite this in vertex form. Okay, and as you see, it was more complicated because I started out with a leading coefficient that is other than 1. In that case, I have to first go ahead and isolate my x variables and then factor that out so that this becomes 1. Once I've done that, I can complete the square, but I have to be very careful on the left that I'm not just adding b squared over 4, but that I'm adding b squared over 4 times what I factored out to keep the equation balanced. And now you see I have vertex form, and here a equals 2, h equals 2, and k equals negative 3. Okay, finally, if you are given the vertex and another point on the graph, you can write the equation of the graph in vertex form. For example, if I'm given that the vertex equals 2, 11, and I'm also told that a point on the graph is at 1, 6, then let's look at what I have. Well, I've got y, because I have a point on the graph. So this is h, this is k, this is x, this is y. So I've got y, I have x, I have h, and I have k. The only thing that I'm missing is a. But since I have everything else, I can solve for a. So I'm going to go ahead and do that. So y is 6. 6 equals a times x is 1 minus h squared plus k. Okay, so this gives me 6 equals a, and this is negative 1 squared plus 11. So 6 equals 9 times 1, or excuse me, a times 1 plus 11. 6 equals 11a, 11 plus a. Therefore, a equals negative 5. Okay, now that I've solved for a, I can go ahead and write this in vertex form. So I have y equals negative 5x minus, I know that h is 2, plus k, which is 11. So again, if I'm given vertex form and a point on the graph, then I can write this substituting in everything I have and then solving for a. And here I found that a equals negative 5. So now I have h, k, and a, and all I need to write an equation in vertex form is h, k, and a. So if you're either given the quadratic equation in standard form or you're given the vertex and a point on the graph, either of those is enough to rewrite the equation in vertex form. Okay, practicing this with some examples. Here I'm given a quadratic equation in standard form and I'm asked to write it in vertex form. Remember that the first step is to isolate the x variable. So I'm going to do that by subtracting 7 from both sides. Okay, so I have y minus 7 equals x squared minus 4x. Next, I'm going to complete the square, and remember you do that by adding b squared over 4 to both sides. And here, b is negative 4, so this is going to be negative 4 squared over 4 equals x squared minus 4x plus negative 4 squared over 4. Simplifying, this gives me 16 over 4. Simplifying further, I get simply 4. Okay, so I have negative 7 plus 4. That's going to give me y minus 3 equals x squared minus 4x plus 4. And what I have on the right is a perfect square. So I'm going to rewrite that as y minus 3 equals x minus 2 squared. Okay, one more step to getting this in vertex form is to move the constant over to the right. And recall that vertex form is y equals a times x minus h squared plus k. So here I have a equals 1, h is 2, so a equals 1, h equals 2, and k equals 3. And the vertex is at 2, 3. And I accomplished that by isolating the x variables on the right, completing the square by making sure I added b squared over 4 to both sides. And then once I had that completed, I could rewrite this in this form, the x minus h squared form, and then moving the constant over to the right. Okay, here, find an equation in vertex form for the parabola with vertex at negative 4, 3 and passing through the point negative 2, 15. So first, looking at what I have and at what I need. Vertex form, y equals a x minus h squared plus k. So to write in vertex form, I actually need a, h, and k. What do I have? Well, I have vertex. So this is h and k, and I have a point. So this is x and y. What I'm missing is a. But since I have everything else, I can solve for a. So I'm going to substitute in here for y, that is 15. I don't know a. I know that x is negative 2. I know that h is negative 4. And k is 3. So solving, a negative and a negative, that's actually a positive. So this gives me 15 equals a. Negative 2 plus 4 is 2 squared. Okay, so then this is 15 equals, this is actually so I'm down to here. I'm going to subtract 3 from both sides to get 4a equals 12. Isolate a. That gives me, by dividing both sides by 4, to give me a equals 3. So now that I have a, I can write in vertex form. I have y equals 3 times x minus h is negative 4. And I can either write this as x plus 4 or x minus negative 4 plus k, which is 3. So this is vertex form, and I accomplished that by recognizing that I had everything I needed except for a. Substituting in, solving for a, and then going back and writing this in vertex form. Okay. And here, a equals 3, h equals negative 4, and k equals 3, vertex form. Okay, again, I'm asked to write the quadratic equation in vertex form. But notice this time, with the standard form, a does not equal 1. Recall that I'm going to have to do an extra step before completing the square in this situation. So first step, isolate the x variables on the right. Now, The extra step I have to take is to factor out a. Now that I've done that, I can complete the square, and that's accomplished by adding b squared over 4 to both sides. So I need to add b squared over 4 to both sides. Okay, and here we have b squared is actually -3. But I need to be careful because I'm not just adding b squared over 4. I actually have factored out the 4, and if I don't add that back in on the left, my equation won't be balanced. So this is actually 4 times b squared over 4. Okay, x minus 3x plus -3 squared over 4. Now, I already have 4 times b squared over 4 here, so I needed to balance it by having that on the left side as well. So this is going to give me y minus 20 plus 4 times 9 over 4 equals 4 times x minus 3x plus 9 over 4. Okay, this is going to give me y minus 20, and the 4's cancel here, which is kind of convenient. So that's going to give me just, these are cancel, I'll just get 9. And -20 plus 9 is -11. So this is y minus 11 equals 4 times. And this actually is a perfect square, and you can check it out for yourself, that this equals x minus 3/2 squared. So this is a perfect square. Now I'm almost in vertex form. I just have to move this 11 over to the right by adding 11 to both sides. And this is vertex form. So again, vertex form, y equals a times x minus h squared plus k. Here I have a equals 4, h equals 3/2, and k equals 11. So the vertex is going to be at 3/2, 11. So this was a little more complicated because I did have a coefficient here, an a, that did not equal 0. So right after I isolated my x variable terms, I factored that out. And then when I complete the square, I need to make sure that I add 4 times b squared over 4 to the left, since that's what I'm adding to the right. And then I just went on and did that. I got a perfect square on the right. And this is going to end up, this is actually all x squareds, and this is going to end up giving me x minus 3/2 squared as a perfect square. And then I just move the 11 over to the right. Okay. Now, find an equation in vertex form of the parabola with vertex at 2, -3, and passing through the point 4, -19. Okay, vertex form, y equals a times x minus h squared plus k. Now, I look at what I'm given, and I'm actually given the vertex, so that's h and k, and a point, that's x and y. Since I have all of these, I can find a. I don't know what a is. That's my unknown. Well, I have y equals -19. I don't know a. X is 4. H is 2. And k is -3. Four minus 2 gives me 2 squared minus 3. So it's -19 equals a times 4 minus 3. -19 equals 4a minus 3. So I'm going to add 3 to both sides to give me -16 equals 4a. Therefore, a equals -4. Now that I've found a, I just go back in here and write this as y equals -4x. And then I have h is 2 and k is -3. So here I have vertex form. I know the vertex is 2, negative 3, and now I know that a equals negative 4, so this is going to be a parabola that opens downward. Okay, this concludes this session of Educator.com, and I will see you again next lesson.